Most people think probability is supposed to tell you exactly what's going to happen. Let's see. Which flavor will I get? I don't know. So probability is useless? Actually, that's not what probability does at all. Probability doesn't predict one outcome. It tells us how likely every possible outcome is. That is the beginning of a probability distribution. The word distribution sounds complicated, but it simply means how something is spread out. Think about a classroom. Instead of asking, what's everyone's score? Suppose we ask, how many students scored 60? How many scored 70, 80, 90? Now we're not looking at individuals anymore. We're looking at how the scores are distributed. That's a distribution. Now let's go one step further. Instead of counting how many, what if we asked, how likely is each outcome? Now, instead of frequencies, we use probabilities. And that's exactly what a probability distribution is. A probability distribution tells us every possible outcome and how likely each one is. Let's build our first probability distribution. Suppose we roll one fair die. Question, what are all the possible outcomes? Perfect. These are all possible outcomes. Now, what's the probability of rolling each one? Since the die is fair, every face is equally likely. Congratulations, you just built your first probability distribution. Notice something interesting. If we add every probability together, we get 1, or 100%. Why? Because one of these outcomes has to happen. You can't roll a 7. You can't roll nothing. One of the 6 faces must appear. That's why every valid probability distribution always adds up to 1. If the probabilities add to more than 1, something has gone wrong. So whenever you see a probability distribution, don't panic. Just ask 3 simple questions. First, what are all the possible outcomes? Second, what's the probability of each? Third, do all those probabilities add up to 1? If the answer is yes, you're looking at a valid probability distribution. Now let's solve something you could actually see in an exam. Here's a table. The question asks, is this a valid probability distribution? Before calculating anything, remember our 3 questions. Are all possible outcomes listed? Is every probability between 0 and 1? Do all probabilities add up to 1? Every probability is between 0 and 1. Every possible outcome is listed, and together they add up to 1. So yes, this is a valid probability distribution. Let's see why. A probability of 1 already means 100% certainty. So a total probability of 1.2 means 120% certainty. That's impossible. So this cannot be a probability distribution. Here's something really interesting. Machine learning models almost never say, this is a cat. Instead, they produce a probability distribution. The model says, I'm 72% confident it's a cat, 14% it's a dog, 8% it's a fox. Notice something? They still add up to 1, exactly like every probability distribution should. So every time you use ChatGPT, or Google Lens, or an image classifier, there's a very good chance a probability distribution is working behind the scenes. Here's the one sentence I want you to remember. A probability distribution is simply a map of every possible outcome and how likely each one is. Let's recap. A probability distribution lists every possible outcome, assigns a probability to every outcome, every probability is between 0 and 1, and all probabilities together add up to 1. If those 4 things are true, you've got yourself a probability distribution. Let's test what you've learned with 3 quick questions. First, is the following a valid probability distribution? The answer is yes. Second, is this valid? No, the total comes out to 1.2. Third, a bag contains red, blue, and green balls. The probability of red is 0.5 and blue is 0.2. What's the probability of green? 1 minus 0.5 minus 0.2 equals 0.3. We've learned what a probability distribution is. But not all distributions look the same. Some are flat, some are skewed. Next time, we'll break down PMF versus PDF, why some distributions show up as bars and others as curves.